Hello and welcome back to Apt for You. In this particular video, we will be discussing a new problem from Heap, and the problem basically is merge k sorted arrays, right? So let us first of all understand what the problem actually is. So the problem says that we are given with k sorted arrays arranged in the form of matrix of size k cross k, right? So basically, two-dimensional matrix is given, and there are k sorted arrays, okay, and they are basically arranged in the form of a two-dimensional matrix. Our task is basically to merge them into one single sorted array. So basically, if you just see the representation of the data that is given, now we have basically k equal to 3. So k equal to 3 indicates that our data structure is like basically the data is stored in the form of two-dimensional matrix 1 2 3, and again 4 5 6 7 8 9. Now this is very obviously looks some sort of sorted only, but anyway, k equal to 3, so we have a 3 cross 3 matrix and the data is stored as follows. Now our objective is to sort them into a single matrix, so basically a single vector array, right? So the output should be something like 1 2 3 4 5 6 7 8 and 9, right? So you can see all are sorted. So this is what we have to do. Now in the question they have clearly mentioned that the time complexity that we should be following is k square log k, right? So we should be basically following the expected time complexity that the question expects us to do is k square log k. So we have to solve this within k square log k, and the expected auxiliary space that they are expecting us to occupy is order of k, right? So basically we will try to satisfy these things. Now there is always a chance you can optimize the code, so that is why I request you, if you have a more optimal solution, then definitely you can solve it, and also you can post those solution in the comment section, right? Anyways, we will stick to this particular problem right now and obtaining these complexities. So yeah, let us quickly start coding the problem. So let me just refresh this particular window. Okay, and now I'll be just increasing the size of the screen. Great. So how do we solve that particular problem? So in this particular problem, now they have now we will basically use the help of a min heap, because we have to sort them in ascending order, you can see, right? So why not use a min heap? Okay, so we will be basically trying to use a min heap. So for that particular reason, first of all, we should try to, now since this all the data is stored in a two-dimensional matrix, we should try to first of all store them in the vector x, right, in a single vector, in a one-dimension vector. So how do we do so? First of all, we have to access the entire array elements, entire matrix elements. So basically I will be using a variable I and j, right? And now what should be done is basically I should run a loop for I equal to 0, I less than obviously the size of the array, right? And that will be nothing but k, why? Because k cross k matrix is given, right? So that is why k and I plus plus, and inside it again you will be writing for j equal to 0, j less than k, j plus plus. So you can clearly see we are trying to access each and every element of the array, right, in this way. Now while you are trying to access each and every element, you should basically push them into a one-dimension vector. So first of all, we should declare a one-dimension vector also. For that for that particular reason, I am writing vector int x. So I'll be using this vector basically to store the elements, right? So I will be saying x dot pushback array of I j. So basically each element of this 2 cross 2 matrix, each element of this k cross k matrix will be pushed into this vector x. So your vector x will consist of all the elements of this matrix. Now the moment you have all the elements of this matrix, what do you think we should do? It's very simple, right? So we should basically now declare our min heap, priority queue integer. Since we are declaring a min heap, so I'll be writing vector int and comma greater int, let's name it heap, right? Now what approach will I follow is basically I'll be just accessing each and every element of this vector x, right? 0 I less than x dot size I plus plus. So I am just accessing each and every element of this vector x, because we know that our vector x now consists of all the elements of this matrix, right? All the elements of the matrix are basically contained in the vector x, like this. Suppose 1 2 now it is already sorted, but generally it will not be sorted, right? So what we will do is basically we will access from this to the end, and we'll push it into the heap, right, that you are creating, that heap you are creating, we'll push it into the heap. So basically heap dot what, heap dot push x of I. So what is happening, basically we are pushing them into the heap that we have created. So finally you can see we have just created a heap with all the elements. Now every time we are just pushing them into the heap, right? So our heap will be created finally. Now what we can do is we can pick up the minimum element every time and store it in the array. So I'll be using the same array x, okay, because now all the elements of this x has already been used for creating a heap, so those values are already preserved. What we can do, for again I equal to 0, I less than x, not x, okay, now don't do this, better would be while heap dot size is greater than 1, right? So as long as heap dot size is greater than 1, what you can do, basically you will just first of all, you see whatever elements were stored in this vector x, all of them have been used to create the heap in this particular code section. So now basically you don't require these elements anymore, because I have already done their job. I have created the heap with them and these data are already preserved there. So basically what we can do, you can just clear this vector. So I'll be just clearing x dot clear, because I'll be using the same space to do some other task. What are the tasks? Let's see, the sorted elements. So while heap is greater than 1, because we know already that a heap has already been created, like somewhat like this, 1 2 3 mean heap, right? 4 5 6 7. Now this particular, basically you can see the array elements were sorted, and hence we are getting this heap. But in sometimes it may happen that the array elements are not sorted. But anyway, the heap properties be satisfied, that is, it is a mean heap. The root element is smaller than the children. So now what we can do is, and now you can see the heap size is not 1, not is greater than 1, true, right? So we will keep on popping the minimum element, the top element, and we will store in this vector x. What we will do, just say x dot pushback, what, x dot pushback heap dot top, right? The topmost element of the heap should be pushed back into the vector x. So here you see 1 will be basically popped, x dot head dot top, heap dot top is basically 1, so 1 will be pushed into the vector x, and then just pop it heap dot pop, right? You will pop it. Now after popping, what will happen, this element will be removed, and again this will be heapified, and the next minimum element 2 will come in the root. Next time again you will find that the heap is still greater than 1, then again we will be pushing 2 here and again popping 2. Next time again 3 will come here. Now next time what we will do, 3, again the size of the heap is greater than 1, so again 3 will be pushed here, right? And again it will be heapified. This will go on until and unless you are left with only one element, that is 9, the last element. You see heap dot size greater than 1. So when you have only one element, like all the minimum elements like 1 2 3 4 5 6 7 8 will be pushed, you will be left with one element in the heap. Now this is equal to 1, so this condition becomes false. Now this has not yet been pushed into the array, so we should push this also into the array. So for that particular reason I will be writing here heap dot push array of, not array, basically x of I. Got the point? Sorry, why x of I, the topmost element of this heap. Now topmost element is obviously only 9, so heap dot top, that's it, nothing else, right? So this finally this element will also be pushed into the heap, right? So why am I writing heap? I don't know. Wait, we are storing them in a vector x, right? So x dot pushback, yeah, this is fine, okay? We are pushing them in the vector x, so in the vector x only 9 will also be pushed. Now you can see you have your elements in the sorted order, in the ascending order, right? So this particular problem will basically be solved like this, one of the possible ways of solving this. Now considering what should be returned, now we should basically return, once this is done, we should return the vector x, because vector x is containing the elements in the sorted order. Talking about the time complexity, you can see basically we are investing order of k square in sorting the elements, right? So not sorting, in creating the single array of these all elements, right? K cross k square, fine. Now when we are creating the heap again, you can see size of x. Now what will be the size of x? The size of x will be basically k square, right? You can see the size of this vector x is equal to 9, which is nothing but 3 into 3. So the size of x square is equal to is k square, and then every time we are pushing the elements into the heap, so k square log n, sorry, k square log k square, because the size of the heap is k square, right? K square log k square, right? And again this particular steps also is taking the same thing. The size of the heap is again k square, and again these pop operations again are taking log k square. Now this k square, this square term can be moved forward 2 into log k. This is constant, so we can ignore. So overall time complexity is of order k square log k, and this is what they had expected us, right? Time complexity. Considering the space complexity, now obviously the space is depending upon the number of list that we are using, right? It depends upon the number of list. You see, the space basically that we are using depends upon the number of list that is being used, right? The space that we are using depends upon the number of list, right? Not number of list, basically the size of k. K equal to 3 means 3 list, so accordingly we will be having some space, right? So yeah, time complexity of this was k square log k. So that's all from this particular video. Let us just now compile this particular code, right? So let me compile it. Yeah, code works fine. Let us submit the code and see if it is working fine. So this was one of the technique of solving this particular problem using heap. So you can see the code has been successfully compiled. Now, so we just saw that the time complexity of this particular problem was order of k square log k, right? Considering the space complexity, obviously that is also depending upon the because we were basically having a matrix of k cross k, and the elements here, all of these elements were basically being stored into a single array. Now the size of this array was nothing but depending upon k cross k, right? So space complexity was also order of k into k, which is nothing but k square. So order of k square is the space complexity that we basically used in this particular problem. Obviously there are more techniques to solve this particular problem in a more optimal way, but my main objective was to show how we can solve this particular problem using heaps. So yeah, that's it from this particular side, this particular video. I hope this video was helpful. In case of any doubt, please feel free to put it out in the comment section. Just like, share and subscribe, and yes, I will also come up with an optimal solution for this particular problem, so stay tuned. Thank you.